Great. And those are our questions we'll come back to. So we could go to the next slide. Great. So let's see.
Yeah. Can I start?
Yes, go for it, Abdal.
Thank you everyone for this wonderful and unique opportunity. My name is Dr. Abdara Makaranga, and I'm talking direct from Tanzania, East Africa, from foothills of Mountain Kilimanjaro. So I'm extending thanks to eDNA Collaborative for awarding me the Nofloro Microgrant. So I'm extending also thanks to Shanari for the effort, because it was very difficult for me to receive those facilities. So what I want to use this kit, actually, we know that here we have the lake natron. Lake natron is a very unique lake because of its chemistry. So it has very high concentrations of salt, up to 60 to 100 gram per liter, and the salinity. So it's a soda lime lake. This lake is very unique because it hosts 75% of razor flamingo. So they are coming here for breeding purpose and nesting. So there is a very huge concern because there is a project going on, especially to extract soda limes and human activity. So this activity together dilutes the concentration of lake and select flamingo for breeding. So our work here, flamingo are specialized feeder. They are feeding only a specific strain of bacteria known as cyanobacteria. So what we want to do to use this kit, we want to use this kit to identify, number one, we want to use this kit to understand the concentration of DNA at Lake Natron, and to use metagenomics, deep sequencing metagenomics, to understand if still we have cyanobacteria, which is a key food for flamingo. This is a key target what we want to do. But we have a lot of questions to know regarding the Nofloro kit because of persistence of DNA. This is very unique wreck because of its concentration, like what I've said. So my question is for me, because I'm planning to go to sample after 2 months, is it possible maybe persistence of environmental DNA by using this kit? Am I able to get a lot of concentration of DNA that can enable me to go further for sequencing to understand the sequence? So what we have done actually, like what I've said, our previous work, we have done a lot of work, especially in Indian Oceans, where we have isolated some unique bacteria for bioprospecting, where we do deep sequencing, and then we understand gene cluster to understand the functions. What does bacteria hold on bioprospecting perspective in order to produce high valuable renewable? So thank you for giving this opportunity, and also I'm still extending my thanks to eDNA Collaborative. Thank you, guys.
Thank you so much. Super interesting project. Should we go to the next one? Great.
Well, I think this is us. Actually, this is a team. So we have representatives of these teams, of this team today. So I think Max, Raquel, and Denise are online as well. So we are I was the representative of the team who submitted the idea, but we are all co-PIs, let's say like that. So in our team, we have many different purposes. So different people from different sites, all of them Brazilian researchers. Denise is working in Santa Barbara, California, and I'm working in São Paulo. Raquel and Max are working down south, and Gisele is working in the center of Brazil. So because of this geographic spread, we have different research ideas, and we gather together to kind of learn how to assemble this kit and make this equipment more accessible to different universities in different sites in Brazil and abroad. So can you change the slide, please? Okay, so this is our plan now. We will probably gather together in the south of Brazil, where Max is working in Federal University of Rio Grande, to assemble all together and then learn how to do this and then spread the equipment to our institutions and probably maybe this year or the next one meet in a congress to spread even more the usage of this equipment so that it can be easily accessible to different researchers in Brazil. So this is our main idea. Okay, thank you very much for the opportunity and for the equipments themselves, right? Thank you, guys.
Hi, thank you for the invitation. I'm Florencia, I'm from Uruguay. I work in the Instituto de Investigaciones Biológicas Clemente Estable in Montevideo, the capital of Uruguay. And we are a group of microbial aquatic ecology. We work with different systems from lakes, ponds. I finished my PhD in Antarctic lakes, where I work with water and sediment samples because I use a paleolimnology approach. And in this moment, I'm starting with samples from deep sea because we are in a very big project which take samples from the Rio de la Plata, which is a big estuary here in Uruguay and in Argentina. So we have very different systems from, for example, coral reef from deep water. We have chemiosynthetic systems, and I'm starting to analyze the concentration of certain sediment samples to do amplification of the 16S gene for bacterial diversity. And also, I will do for the first time metagenomics. So I have only 10 samples, and last month, I did the DNA extraction, and it was the first time I used the DynoFlyer because here we have a nano drop, and also we have a service of sequencing, and they use because you can do the DNA extraction and give the sample to the service, and they use qubit for the DNA concentration, but I try to check with DynoFlyer, and the thing is that, as Ryan said, I found a lot of difference between the nanodrop, the qubit, and this equipment. But I know that sediment samples are very complicated because there are a lot of organic matter and a lot of stuff. And I know nanodrop and this have different, I don't know the word principles, because one is with fluorescence and the other is with absorbance. But as you can see in the next slide, I I put this difference because I think that with sediment samples is the most important difference. And I don't know if you have the same results or similar situation, but I think this is because the kind of samples.
Yeah, I think this is a really is important question, Laurencia, yeah, I I think the comparison, if you compare the Dynaflor to the qubit, it's a more, apples to apples comparison. And the question is, can you believe, what numbers do you believe? And the gold standard, if we think of the gold standard as qubit, because it's yeah, in principle, right, it should be the most accurate thing. I
Mm.
think that has to be the measurement that you're comparing to. And Eiley refers to the nanodrop as a random number generator. And I don't want to believe that because I love the nanodrop, but but I do think it's worth doing that comparison. Nanodrop and qubit will be very different. I've done that myself.
Yes,
I've
yes.
the scatter plot of like one thing versus another, and they can be very different. So not to say that Dynafloor is the world's most perfect tool, but it is the equivalent tool is the qubit, I think, and not the nanodrop. And so I don't know that I would lean too much on this comparison.
Mm.
Um, it's really that second row that's the most strange, right?
Yes.
The other ones are okay.
Mm.
So maybe just trying that one again, or as you said, because it's sediment, you have
Mm.
very different chemical properties of that, and you could imagine it doing very different things.
Mm.
In which case it's difficult. You try the extraction again, right? Or you clean the extraction one more time before you
Yes. And
analyze.
also maybe because for dinofluor, I have to dilute the sample, but this is not the same for nanodrop because you don't have to dilute. So maybe this.
Yeah, I don't have a better answer for you, but I think that those are some ideas.
Thank you.
Thank you, Florencia.
Hello, everyone. Can you hear me? Perfect. So thank you for this opportunity to share some of the research activities I am doing as an intern in the Laboratorio de Genética here in Argentina, in Santa Fe province. My name is Tomás Ezequiel Borré. I'm an undergrad student pursuing a bachelor's degree in biodiversity. So some of the activities that I do in the lab is the environmental DNA extraction from water samples, specifically from urban lakes and parks. And I am currently working on the development and validation of species-specific qPCR assays. And these assays work for the monitoring and detection of amphibian species that inhabit these environments, these urban environments. And all of these activities I am doing as an intern under the direction of Dr. Patricia Amabet, which is the director of the laboratory. And in the next slide, I'm going to speak some of the other activities. Yeah, thank you. So another activities that I am also helping is to develop and validate a species-specific qPCR assay again, but this time for the detection of an endangered bird species, which is the yellow cardinal, again in environmental DNA samples. And also what we do in the lab is we work in the assessment of vertebrate and invertebrate communities through metabarcoding in environments with different land uses. So this is very important because Argentina is a country with an economy based in agricultural activities. So it's very important to have these monitoring tools very well tuned. So this opportunity that I have with the Environmental DNA Collaborative makes it so much easy to optimize our workflows because until now we relied on another laboratory, another nanodrop that is located in another building from the university. So this could work as an accelerator from our workflows and giving us more comfortable working conditions. So thank you very much.
Well, hi, my name is Marta. My situation is really similar to the one that Tomas said. I'm also an undergrad student. I'm from Barcelona, but right now I'm in Argentina, in Bariloche, as part of Greenbeak, which is investigations in conservation biology, and I'm specifically in the genetics part of it. And during my time here, I've been a part of two projects. One is about population genetics of South American vultures, specifically Vultur gryphus, so the Andean condor. And well, I used the Dynafluor to assess the DNA concentration before moving on to other steps like creating NGS libraries. And similar as Florencia, I also found some differences between fluorometry, spectrophotometry, and Dynafluor concentration. I thought that it was because, as you also said, like you use different dilutions and different pipetting systems for each one of those, and I think that there can be like a lot of experimental issues with that. But I also have some questions that maybe we can assess later in terms of the fluorometer that's better and stuff. I don't know if you can move forward to the other one. Okay, this is the project that I've been principally working with, which is eDNA metabarcoding to integrate molecular data into urban wildlife research. There's this project called UWIN project that tries to identify the urban wildlife composition using a combination of visual and acoustic data. And now we've added another layer to it, which is molecular methods using eDNA metabarcoding, and to compare the effectiveness of each method in detecting terrestrial species and assess the usability of eDNA for species detection. Here, there's a map of Bariloche in which you can see like the different sampling points. It's from freshwater bodies. And like I'm really glad to have the Dynafluor with us, because same as Tomas, we also relied on another institution to do the DNA quantification. And I think it's a really great opportunity to have this small machine to work with. That's pretty much it.
And so, can I? Oh, great! And there's the last one. So good timing. Can I ask about that, Marta? That last slide. So what is the spectra? The two instruments is Dynafluor and a spectrophotometer
Yes, and also a fluorometer that we've been using with Pico Green.
with Pico Green. Okay, yeah.
Yes.
And this is a world that I haven't been in the lab a long time, so I'm a little bit at a disadvantage, sadly. So yeah, you might expect small differences, but those are big differences between there.
I know.
And Florencia had that one really big difference. So I might expect a difference in scale, like that you have like parallel lines with an offset where they because they're more sensitive or less sensitive depending on the instrument, depending on your fluorescent agent that you're using, Pico Green, and I think I said cyber before in the chat.
Yes.
The qubit reagent is so expensive that you try and avoid buying it if at all possible. And so we've been testing that. We test against the qubit reagent, and then we try it with Pico Green as well, and that seems to work. Do you ever do replicates, like triplicates, so that you can know what that noise is?
Yes, we've been doing that. The thing is that, like, specifically, the issue came with the DNA samples that were extracted from blood samples of the Andean condor. So since like the Pico Green, the fluorometer that we use works at a little scale, so we have to dilute the samples a lot, like 150 or more. And so that in itself, it adds a lot of variability. Whereas in the Dynafluor, we were trying to check which dilution would work better and etc. And I feel like it's just like preliminary results. We should check it again. I would really like to know how you guys do it when you have like a high concentration DNA and also with a low concentration DNA. Because with the eDNA, we have the low concentration, but with the blood samples, it's a high one.
Yeah, it's a great question. We work mostly with eDNA, so it's mostly low concentration. If we have a high concentration samples, just like you, we dilute it, and then try not to mess with it. You know, like you
Yeah.
dilute it
Hey
once.
Ryan,
Yeah,
sorry, we have an additional slide
yeah,
that was added this morning. Emmett would like to present. Can
of
we
course.
do that real quick before we get into like the broader discussion?
No problem.
Thank you so much. Give me 1 second.
Sorry for the interruption, folks. I had a slide and then I deleted it because I wasn't sure what the format was, and so I just quickly remade it and tossed it in. So apologies for the interruption. But I just want to say, first of all, I'm really excited to be introduced to this group and hopefully meet more of you this year in Seattle. I'm planning to be at the conference, so I'm really excited about that. And so, thank you. And thanks also for sending us the Dynafloors. So yeah, my project. So I'm based in Indiana in the United States. I'm at a small college, and our goal is really to give students research experiences that they can use in, helping them go on maybe into graduate work or things like that. So one of our trips that I get to lead, and I'm so lucky to get to do it, is to go to Iceland every summer and take a group of students on a field research experience there. And for the past couple of years, since the summer of 2022, we've been collaborating with another university in Connecticut, as well as our research station out in Skalnes, in East Iceland, to try and monitor the ecosystem health of a fjord out there called Seyðisfjörður, because they were going to build fish pens for Atlantic salmon in this fjord. And our collaborators who live there and work there were like, we want to get some data before this happens. So maybe we can compare to what is going to look like after they put the fish farms in. And so we've been going and collecting water samples and other things. I'm mostly involved in the eDNA component there. And so we have a lot of samples. We have not yet got to the sequencing of those samples. I've finally got some nanopore equipment that I'm really excited to try and use for that. But the Dynafloor is a perfect little device because we are trying to establish a lab over there in Seyðisfjörður that we won't have to bring our samples back to the United States to process them because that's a pain in the butt. And so this is exactly the kind of tool we've been looking for as a, easily transportable small device that can get us the measurements that we need after we do our DNA extractions. And hopefully we can go, through the whole workflow over in Iceland. That's our goal, is to not have to bring any samples back to the US. And also to, help empower the residents of Seyðisfjörður maybe to be able to work on this project. So it's a lot of fun. And yeah, so I'm just excited to chat with you all about how things are working. I will also just add my students did build, we got 3 Dynafloors. We built 3, 2 worked. One out of the 2 that worked gave us really good values when we calibrated it, a good R squared value. So we're kind of still also at that troubleshooting stage of like one of the motherboard or the little Arduino boards seems to have like a flashing yellow light. We weren't sure what to do about that. And the other one just had some real strange values when we tried to calibrate it. And so that's where we are. But the students had a great time building them. So thank you for sending them.
Oh, wonderful. Thank you, Emmett. Yeah, I would just say for troubleshooting too, I really recommend reaching out to the Dynafloor folks on uh you can find
On GitHub,
on
right?
GitHub, yeah, you
Yeah.
can find
Yeah.
their you can just message them in there, and they are really responsive, and they actually are expecting a lot of questions because of this project. So they were bracing for lots of questions. So if you have any, please do reach out to them. Um, and it's interesting. We definitely we troubleshooted about 20 of them when we held our class at Friday Harbor Labs, and there were, I think maybe 3 or 4 out of the 20 that didn't work, and we were able to get them all working after a while. So definitely don't give up.
And Shayna, to add to that, I think obviously it would be better if it works the first time, right? That would be that would be the best outcome. But uh, that being said, and maybe Florencia can agree or disagree, but I think when something doesn't work, then the effort of fixing it makes you understand it, right? You have to take it apart and you have to say, how does this work? And how can I, and then in fixing it and getting it to work, you develop a sense of ownership and it's like empowering actually to be able to fix a thing that didn't work. And so even though that's not the best outcome, maybe it ends up being a long-term good because you end up learning something and feeling like you were part of the process, you know? So yeah, and I agree. I think the people, the Dynafloor designers on that are linked on the GitHub website, they are very responsive and they will absolutely help with that sort of very technical stuff. I think the Arduino flashing yellow doesn't sound good. I think probably that seems like a software, or firmware problem on the Arduino, and so like that, there's probably a straightforward way to do that. We saw a couple of other common. Oh, look, so other instructions there. It looks like that Emmett has posted. Thank you for that. And there were a couple of other common reasons it didn't work. Like there was one wire that was easy to put in the wrong place. And then once we got that sorted out, everything was fixed. Or if you have really values that are very unpredictable, I think there are two optical elements, the two little filters in there. And if there's like dust on those, it'll mess with it in a way that is bad. So those are easy things to look at. I don't immediately have any other ideas.
Yeah. So I put a few questions. Thank you, Ryan. I put a few questions in the chat, which we can just use as to open up to general discussion. So I know you're probably all at different stages of using your Dynafloor, putting it together, etc. But we were really interested in, finding out if you've, assembled it, if you've used it. This feedback that we're getting is excellent. And also, yeah, what you intend to do, any work that you want to do and kind of bounce off other people. We'd be excited to just kind of open the conversation up. So.
It's like the first day of class where no one wants to speak.
I can begin if you want.
Hello, everyone.
Hello, yes, feel free to speak.
Yeah, I have one questions which I want to know because I've been working in lab, especially on DNA extractions and DNA purification and DNA quantifications, and most of the time we use nano drop. So in nano drop, we know that if there is any kind of contamination in the sample, you can understand it by checking that wavelengths, absorbance. And then that it will make you to make a decisions whether you have to purify your DNA extracted and then you send for sequencing. So because my work, I'm planning to use the kit for quantifications because now I was working out abroad, now back home, so we don't have even nano drop. So I want to use this Dynaflow. So I have the questions because once I quantify my DNA, it will tell me, I think also maybe there is a contaminant, maybe there is a salt concentrations, maybe there is a protein, because after extracting the sample, I will send the sample again abroad for metagenomic sequencing, for deep sequencing. So is there any response regarding this? Thank you.
I want to make sure I understand the question. Is it that when you think that the extraction is not very clean, and so you think the measurement of the concentration is wrong? I think I didn't quite understand the question there.
I mean, the question is the normal nano drop.
Yeah.
It used to give you different parameter like whether your sample is contaminated, because I'm planning to measure concentration of DNA.
Yeah.
So if your sample is contaminated with RNA or salt, it will give you, because you cannot send the sample for sequencing if the sample is contaminated. Yeah. So because now I'm planning to use Dynaflow for quantification of DNA before I send for deep sequencing, metagenomics. So it will give me the same like concentration of other contaminant like the RNA and the salt, because I'm planning to sample on Salt Lake.
Yeah,
the lake is highly concentrated with salt.
It is
So that is my
very intense environment, obviously.
Yeah.
So so the Dynafluor, because it is a fluorometer, it will just measure the concentration of DNA and RNA. I think just DNA, depending, right? The fluorescent compound binds to the DNA, double-stranded DNA. And so it will not tell you about the purity of your sample. It will not give you that measurement. So the thing to do, I think, and other people might have better ideas, is if you develop a DNA extraction protocol that works really well for the lake, so that it gives you a clean sample from the lake, then you start to trust your extraction is clean. And then you don't have to worry about it, the question of is it clean? You worry only about the question of how much DNA is in there. And then this is the instrument for that. But I think if you need a measurement of purity, it's a different measurement. You need a different instrument for that.
Thank you, sir. Thank you.
Yeah. I was starting to type this out, but one of the things that was difficult for people with the NanoDrop is the graphical interface on the computer is not very good. It's a little bit it's a little bit basic, and so I wanted to make a draft of a better interface so that it was more user friendly, and I created one with AI because I am not a great Python coder. And so we made a draft, and that is here. I cloned the repository from the creators of the Dynafloor and made a draft of the different GUI, the graphical user interface code. And so you can find that in the link that I just dropped here. There's a little folder called Python, and that gives you that graphical interface. So the nice thing about this project is it's entirely open source. You can change it. And particularly with AI tools, you could download this and say, make it different. Make new Python code that would give me some additional um, uh, function, or not function, but change the aesthetics or make it better in some way. You can do that. It's entirely open source and open access. That's also true of the hardware. If you are feeling very ambitious or creative, you can take apart the hardware and change it. Like you want to measure single-stranded DNA, or you want to measure the fluorescence of something else, like you make a LAMP assay or a CRISPR assay that fluoresces at a different wavelength. No problem. You can just put in a different filter and measure a different wavelength. That's a project. That's right, but it is a possibility. So I like the idea that it's empowering that you can own your tools and you can change your tools.
Yeah, thank you.
I have a question for the people that have used it. As I said, I've only used it twice, so I'm still like trying to understand it and to optimize the process. But for now, I just used it with Pico Green, and I tried it once with CyberSafe, but I'm not sure if the CyberSafe that I was using was was the proper one, like it was a good quality one, etc. Because it was, you know, those reagents that stay in the lab for a long time. And so I wanted to know if anyone had used the dyno with CyberSafe and to explain the experience, if it worked, if it didn't, etc.
Oh, here's where we really need Eiley. I'm forgetting whether we used Pico or Florentia might remember from
I'm
last
pretty
summer.
sure we use Cybers.
I think we used Cyber and not Pico Green, right?
Yeah.
Yes,
Yeah.
we CyberSafe.
Yeah.
Yeah.
And so I think it seemed like it worked fine. It's is it a slightly different? I think it works at a different concentration. Is that right? Marta, what was your experience with that?
No, I think that my issue was that I did not correctly set up the concentration in which it worked, because I had like a vial and an aliquot that I was not sure about it. So if anyone used CyberSafe and could give me a heads up on the concentration that it was used at and like a bit of the protocol, I would be really thankful for that.
Yes, we have very good explanation in the protocol from Friday Harbor.
Yeah, great. Let me find that, and Marta, I will email it to you after this meeting or sometime today.
Thank you. Thank you.
And we can send that out to the whole group because people will be interested. CyberSafe is useful because it's if it works, it's much cheaper and it's supposedly is safe. It's not toxic, so that's nice.
Yes, Melvin.
Yes, hello everyone.
Hello.
Yeah. So thank you so much for the organizers, that is Shana and Ryan, for organizing this meetup. It's really good. So yeah, my name is Melvin and I am a PhD student at the Faculty of Sciences, Mohammed V University. So my research also focuses on the assessment of fish and mammals in aquatic systems using eDNA metabarcoding. Yeah, so it's unfortunate that I missed last year's summer school at the Friday Hill Harbor labs because of visa delays, but I'm happy to see the advancement in how people have gone through even acquiring the microgrants to be able to continue with their research work, and especially with the use of this new equipment known as the DynaFlow. It is my first time hearing this equipment. But for my case, I have used the qubit and nanodrop to check the concentrations of eDNA in water samples. And I normally get low concentrations, but I am surprised to see that using this equipment, people are getting high concentration using their eDNA samples. But what I have learned and I've heard from the team is that this equipment is similar to qubit. But my question is, why are the concentrations so high, even when people have already diluted their samples? Yeah, so I'm surprised to know about it, but I would like also to one day be able to use the equipment in our lab to be able to check the concentration of our eDNA samples and also check the comparisons between the different equipments that we have using this equipment that is being used by the eDNA collaborative team. Yeah, so thank you so much and happy to see you all.
You too, Melvin. I have an answer for that, but let's let Nabil talk here first.
Hello, everyone. So let me introduce myself. I'm Nabil Amor from Tunisia. I'm associate professor in bioinformatics at the University of Tunis Al Manar. My research focuses on the biodiversity, genomics, population genetics using eDNA, particularly targeting understudied and endangered species like bats, reptiles, and carnivores. But also, I'm engaged in several projects and in several projects in capacity building to transfer the use of a new technology like the NGS and portable laboratory like the use of the Bantu lab, which is a small lab we can transport to the field, and the MinION for the sequencing, and the DynaFlower for the quantification of DNA in the field. I'm very happy to be selected for the DynaFlower Microgrant aimed in developing a regional DynaFlower node. Through this initiative, I will be established a regional hub for distribution and capacity building in North Africa, especially, and also in other region here. So my goal is to leverage this platform to support research, training, outreach in Tunisia and the border region, making low-cost eDNA tools more accessible for student, researcher, and also for citizen science initiative. We have a lot of association here interested in the biodiversity and aquatic locality, and also in several region, desertic region also here. So I'm very excited to be part of this community and exchange ID, learn from you, your experience also, and explore potential collaboration. Thank you.
Thank you so much, Nabil. We're really excited that you're going to be offering the DynaFloor to folks across North Africa. So please reach out if you need any help with that. Yeah, thank you.
Yeah, that is so cool. I love I love that idea. Um, Melvin mentioned there's a question in the chat. Melvin mentioned missing this summer class last summer, and Melvin, we feel so terrible for the visa situation. And so I again I'm sorry so much. I wish that had turned out differently. But we're so glad that you're here with us now. And to the question about whether we will do this in the future, we hope so. It takes a long time to get the class. We need about almost a year and a half, about 18 months of lead time before we can teach a class at that facility. This is the laboratory facility of the University of Washington where we work, Shayna and Justine and I. And it's a beautiful facility on an island, but you need to plan way ahead to be able to have access to it. So we're trying to do that now, and we will let everybody know if we have that opportunity in the future. We'll send that out by email. We have a list serve email sign up, so make sure you sign up for that if you're interested. Also, a Slack channel, the eDNA Slack channel, we can send out a link to that, which is really useful for connecting people. But yeah, hopefully we can do that in the future. While I'm talking, I'll also mention the eDNA, the Global eDNA Conference is coming up. We're hosting that or co-hosting that in this coming October in Seattle. Um, we we are aware, obviously, of the disasters that our country is creating in the world for other people, and this is a tragedy on many levels. And as a result, it is quite possible that people, will have a difficult time traveling or do not want to travel to the United States, and that's entirely understandable. So hopefully we can, all we can do is hope that the world improves in the next 6 months, and that we get to see people in person. But otherwise, we will just do our best to keep on trying to support people around the world and try and be helpful where we can be.
Thank you, Ryan. Yeah. Um, we have a couple minutes left here, and I know that there's been a lot of chat in the chat there, including some of the more details of this discussion about Qubit versus Dynafloor. So please check that out, and hopefully that answers your question as well, Melvin. Um, does anyone have anything else they would like to discuss or get into with that? Or Melvin, yes.
Yes, I'm sorry, but there's something that I would like to ask. This is concerning the call for microgrants. So when is the call announced and when do people apply? So that at least if it's announced, we should not miss the opportunity. Thank you.
Yeah, that is a good question. We develop new microgrants all the time, so we don't have a regular schedule with releasing them, and they're always a little bit different. So the last microgrant we released was for support to travel to support to register and stay in Seattle for the conference. And I'm not sure what our next microgrant will be. So we don't have a regular schedule of releasing them. We try to rely on opportunities and collaborations that come our way. So I'm sorry I can't give more of an answer to that, but we do always release them on our listserv and on our Slack channel as well. So if you are not on the listserv, please email us at the eDNA Collaborative and we will put you on there.
I just put in the chat, but now this was one of your questions for discussion here, Shayna.
Yes.
If we could offer new microgrants or new opportunities to people, what should they be? We are trying to be helpful. So if this is one piece, right? The fluorometer is one piece. What else do you need, or what would be useful? We've done bioinformatics training in the past. There's a really nice company out of Germany called Physalia that does these really good trainings, and so we've paid for um, tuition for people to take bioinformatics trainings because that's often a difficult part for people. We have done the mini PCR machine, for example, that we can send to people. And so we are looking for ideas. So if there's a missing piece, please tell us what it is, and maybe we can make it work.
May I? Oh, go ahead. Go ahead.
No, it's okay. Go ahead.
Well, I think that including Nabil mentioned that he's been using Bentolab. And I think that
Yeah.
Emmett mentioned that he would like to kind of establish on-site laboratory, right? So I think that kind of equipment would be great because in our team, Denise also plans to use it. Max wants to bring it aboard in the ship. So this is really useful. I'm not sure if it's the only piece of equipment that brings together different kinds of equipment, but merging it with Dynafor, that would be great. To kind of work with the samples in the field, that would be really, really nice. Thank you.
Yeah. Thank you for that idea, Gustavo. Yeah.
In fact, I used the Bantulab and the MinAyn for the barcoding of several samples of carnivore and bats. So I used the MinAyn for the sequencing, but for barcoding, for generating the primer, I used the ONT barcoder. It's a small script, Python script. It generates the primer based on universal COE cytochrome oxidase primer. Then another script to demultiplicating the reads generated from the MinAyn. It was very easy and very successful to generate the barcode for carnivores, for bats, for several species. And also we detected for the first time a small population of the leopard in Arabia. It's a species that was mentioned that there is no samples, there is no individual in Saudi Arabia, but we found a small population for the first time, I think, since 20 years, using this kind of portable laboratory. So It's very good for the field work.
Wonderful. And thank you, Nabil. And yes, Dr. Abdallah.
Yes, thanks again. I want to say like ear depths matter, and if you don't sequencing it, you cannot detect it, and you cannot protect it. So for me, I'm working with layer microorganisms, and I want to turn this data for decision making. So I want to have very strong evidences. So I have these concerns. What I know back that I used to have a nanodrop results, and then I have to confirm again by learning J-electrophoresis. And together with my DNA, I have to send for sequencing. So I'm working with most of my project companies in Netherlands. So is it possible now to send it, the data of dinofloro together with maybe jet electrophoresis for the company for sequencing? What is your experience regarding this? Another issue, if I get opportunity for sequence analysis, especially metagenomics, it will be very great because of database. Because if you go to taxonomic richness classifications, most of species are not ready sequenced. So I have to use far depths to go for gene to predict what is going on the ecosystem rather than using taxonomy. So database is still the challenge. If I get training also, it's much better. Thank you for opportunity.
I am trying to type as fast as I can, and it's too many questions all at once. Um, Briefly, because we have to go, and it's we are at the end of the hour. Different service providers for DNA sequencing will require different things. Usually, they only ask about concentration. They don't ask about purity. But I think one thing I have learned is if you can send the sample itself to the service provider, then it becomes their problem. They have to extract the DNA cleanly. It's not your problem, and it's nice to give it to the people who will finish the lab work instead of doing a piece of it yourself. So we could talk if you would like. We could talk more about that, or you want to email me and we can come up with a solution for you.
Thank you. Thank you.
Yeah. Well, I think we are out of time, but we got some good, really good ideas here in the chat. And Shayna, do you know, can we keep that chat when we sign off here? You're the host, I think.
Oh, I wonder if I can. How do I do that? Probably, yes, I'll just cut and paste it right here.
Yeah.
Yes, thank you for everyone for coming today and for exchanging your ideas and for taking part in this. This has been a fabulous exchange of ideas. We're here if you want to reach out to us, please do. And Justine is also going to send around some of the follow-up resources and the recording. So let's keep this conversation going any way that we can. So thank you all.
Thank you.